All right, in this video, we want to prove this trig identity over here. And this is a slightly more difficult question. Although it's not the hardest that I've seen, I would classify it as a slightly harder one. So we're only going to focus on one question for this video. Now, whenever you have sine 3x and cos 3x, typically you want to start by breaking those down. And the way you usually break them down is you just turn them into sine of 2x plus x so that I can break it down using my compound angle formulas. I'll do the same for the bottom. Obviously, the left side over here is the more complex one, so for trig identities always work with the more complex side. And then using my compound angle or addition and subtraction formulas, I'm just going to break down these two. So at this point, I already assume that you know those formulas. If you don't, you should be going back to practicing them. That's sine A cos B plus cos A sine B. That's the addition formula for sine. And let's do the same for the bottom for the cos one. Cos A cos B minus sine A sine B. That's the addition formula for cosine. The next thing I want to do is I want to get rid of all these double angle formulas, all the sines and coses in the top and in the bottom. Let's do that in this next step. I'm going to write this a bit smaller and squeeze it in because this is going to take full width of the page. So sine 2x, I only have one choice, and that's to turn it into 2 sine x cos x. I'll do the same for this one here, but I'll write the cos x first, just so that it's a bit more neat and it looks easier to distribute. But there's no difference. I'm just converting that to sine x cos x, and I'm writing it after the cos x. Since they're multiplying, I'm allowed to do that. For this one here, I have three different choices of what to convert cos 2x into. Cos square minus sine square, 2 cos square minus 1, or 1 minus 2 sine square x. And the option that I'm going to pick over here is going to be 2 cos square x minus 1. And the reason why I'm going to pick that option is because I know cos times sine cos is going to give me sine cos squared. I want the exact same thing here so I can combine like terms. I have a sine here, so I'm going to convert this to the cos square one, so I'll get sine cos square as well. That was a bit complicated in terms of explaining it, but I hope you understood it. If you don't, just follow the steps and you'll kind of understand why as I do the next step and expand. Now again, I'm going to write the sine x first, just like I did over there, so it just looks a bit more neat and it's easier to distribute. I'll convert this to 2 cos square minus 1. So now when I multiply this out, I'll get sine cos square. And over here, when I multiply this out, I'll get sine cos square, and those will be like terms that I can combine. Let's do the exact same thing to the bottom. Cos x. Now I have a regular cos 2x over here. I don't know which one to convert this to. So I'm actually not going to convert it just yet. I'm going to leave it the exact same for now because I don't really see too many like terms that I can combine with just yet. I'm just going to leave it like that. For the middle one over here, I have cos times cos 2x. So I'll just write the cos first. And for the cos 2x, I'm going to use the same logic as the top. I'm going to convert to 1 minus 2 sine square x, because when I expand this out, I'll have sine times sine cos, which is sine square cos. So I want sine square cos over here. So I'll convert this to 1 minus 2 sine square x. Over here, I'll write the sine x first, and over here, 2 sine x cos x. So if we expand this out, I had no choice over here. I'll get sine square cos. I wanted sine square cos over here as well, so I could combine like terms. That's why I chose 1 minus 2 sine square x. So this is one of the complicated steps in this problem that makes this such a tough question. Next step, I'm just going to expand all my 4 brackets. I still don't know what to do with this cos 2x, but I'm sure I'll find out at some point at the end. And now I'll just combine like terms also. So sine x and negative sine x just cancel off. I have 2 sine x cos x. That doesn't combine with anything. And 2 plus 2 is 4 sine x cos square x. And in the denominator, cos x plus cos x is 2 cos x. Cos 2x. I'll still leave that same. I don't know which one to convert to just yet. And those two combining will give me negative 4 sine square x cos x. Okay, at this point here, I guess there are a couple of things that I could do, but what I notice is that if I put these two terms over here together and I common factor out 2 cos x, I'll have 1 minus 2 sine square x, which I can then simplify to cos 2x. So that's what I'm going to proceed with. I'll write the top the same for now. I won't really simplify the top, although I could common factor in the top as well. I'll just save that for when I'm doing it in the bottom. So over here, I'm just going to write the cos 2x at the front. And over here, I'm going to factor out of these two terms 2 cos x. So if I factor out it from that, I'm left with 1. And over here, it's going to be minus 2 sine square x. And like I said, the reason that I did this is so that I can have a cos 2x, basically convert that into a cos 2x in the next step. So let's do that next step over here. And now I want to common factor out the top and the bottom. So in the top, I'm going to common factor out 2 sine x cos x. Left with 1 plus 2 cos x. In the bottom, I'm going to factor out cos 2x. And I'm left with 1 plus 2 cos x. And now these two can cancel. So I'm just left with 2 sine x cos x over cos 2x. 2 sine x cos x is just sine 2x over cos 2x. And then I'm left with tan 2x, and that is the final solution. I guess it matches the other side. Now, there may be quicker ways or better ways to do this problem. I'm not sure. That's how I would solve this one. Pretty tough one, like I said. But if you have a quicker way, let me know in the comments. And if you made it to the end of this video and you found this content helpful, please hit that like and subscribe button. Thank you for watching and have a wonderful day.